Okay, today we're going to be doing some work on experiment number 9. That's the one for carbohydrates. Remember, we talked about carbohydrates, which ones we'll be reducing and which ones we're not. Reducing ones happen to be the aldehyde ones, and if they have a ketose group on them, they don't reduce. There's an exception to that rule, and that was sucrose. You can remember back from lecture where we talked about why sucrose is going to be a reducing sugar versus it should not be, because there's no, the other group that's on it is the fructose. The fructose is not a reducing sugar. Let's go back and take a look at it. Remember, we're going to use the Benedict's reagent. It is a nice blue solution. Pull it up in the thing here. You can actually see the color, hopefully. We're going to put 2 milliliters of this blue solution, and you see it, in each one of these things. This will be the glucose one. Fructose. Sucrose. Lactose. Starch. The last one is the unknown. We'll try to match up what we might think this might be. Okay, all of these now go into the hot water bath for a while. You take a look at these, you see most of these have a reddish brown color in them. That's because all monosaccharides will always be reducing because of the keto-eno tautomerism, I think is the name of it. So they will make that functional group come back to be an alcohol group on the end if you put it in with acid. This stuff is acidic. The things we don't have anything showing on is the sucrose. And sucrose is glucose and fructose. And then we have an unknown over here. Everybody else is all colored except for the unknown. I think you can probably figure out what the unknown must be. You can see the colors over there. Again, give me the list. Glucose, fructose, sucrose, lactose, starch, and the unknown. That's the order that they're in. Glucose, fructose, sucrose, lactose, starch, and the unknown. Okay, the next test we're going to be doing is Solowynoff's test. This is testing for ketosis. If there's one there, it should be a rapid color change to reddish looking material. This is what we have going so far. Nice and clear. The glucose, fructose, sucrose, lactose, our starch solution, which is kind of cloudy. You can see it. Here it is. And our last material. Last one is the unknown. Okay, one more time, because I think I had the camera in the wrong spot. A nice clear solution for the glucose. Nice clear solution for the fructose. Clear solution for the sucrose, lactose, starch, kind of cloudy, and a clear one for the unknown. I'm going to add 2 milliliters of the Celewan-off solution to it, and we're going to see if things change rapidly or take a little bit of time to do it. Starting out with the glucose. Takes about a minute for any color to develop, so okay, let's take a look at what happened over a little bit of time. Actually, I had to put them in the water bath to get them to go faster, but that's okay. This is glucose. Notice it's just a kind of a slightly tinted material, but look at fructose. Fructose, we always know this is the ketose. Followed by sucrose, and sucrose will change because it can go back to being remember what sucrose is, a combination of sucrose and fructose, and we can make that fructose group come back on there with that carbonyl group on it, the ketone group. That's why that one changed. This happens to be lactose. That's glucose and galactose together. Neither one of those are ketoses, even if you do hydrolyze it a little bit, followed by starch, and starch is just a polymer of glucose, so there are no ketose groups on it. And then here's our unknown. Which one does it look close to? Can't hardly tell. So it'd be one of the two of these, I would think. I'll let you guys make a decision. I'll put this. Okay, now we're going to do the iodine test. Again, these are the same 6 things we started out with: glucose, fructose, sucrose, lactose, starch, and the unknown. As you can see, they're all nice and clear. from the start. Except for that starch, which is a little bit cloudy, but that's not what we're looking for. We're looking for a color change. We'll add our 2 drops of iodine solution to each one of those test tubes and look and see if we get a color change at all. Take a look at your notes. You'll see if the thing turns nice and blue, it's the polysaccharide that's all amylose. If it turns purple, it'll be a polysaccharide that includes amylopectin in it, in the starch. So we're going to check, and then if it isn't a starch, you shouldn't see anything at all. So here we go. Okay, getting back to examine our samples again. Again, glucose and fructose, still nice and clear. Sucrose and lactose, still clear. But the starch has turned a purple color. As you can see, is not that clear blue because this starch is not amylose. This is an amylopectin mixture and amylose, but mostly amylopectin. Our unknown also is not changing color. So the only thing we should see a color change on is with the starch itself, nice and purple. Again, for comparison.